So, beautiful people, we are working on the running, skipping, and hopping lab, and we are working on the question, what does constant motion look like on a velocity time graph? We've done position time graphs up till now velocity time. So flipping it over, this is what your position time graph should look like. We went to a maximum of 20 meters, and whatever the time period was, I'm saying that my longest time was 10 seconds. And I've got 3 of the 5 motions. I did 3, you'll do 5. And I have my fast motion here. It took only 4 seconds to travel the 20 meters. But this one here was much slower. To go 20 meters, it took a whole 10 seconds. And this one here starts at 20 and moves down towards the origin. And I've calculated my slopes for all of those, and I need to do that because slope is equal to the velocity. So I have velocity, I have slope in my data table on the first page. You can also go back and label that as velocity because the slope tells us how far in what time. That's velocity. Now your velocity time graph is different because your velocity, did I make a mistake? Negative. Your velocity graph needs to incorporate this negative 2.9 meters per second, your negative velocity. So to get negatives on a graph, we need to go into the second quadrant. So your velocity time graph is going to look a little bit different. I'm going to line up my y-axes, and I'll show you why in just a little bit. And this is my y-axis. But instead of 0 being down here in the corner, I need room for negatives down below. So my 0, my x-axis, is actually going to be right here in the middle. So now I have my positive quadrant and I have my negative quadrant. Now this is velocity in meters per second. This 0, by the way, is not a position. This 0 is not like that 0. This is the origin where it is 0 meters. This is 0 meters per second. This is where it's not moving. So now I need to put my 3 motions onto the graph. My first motion is 5 meters per second, then 2, and negative 3. So I need to set a scale that's going to get me from 0 to 5 going up the side, and that same scale has got to get me to negative 3. So 1, 2, 3, 4, 5 is what I'm going to do. Yours will vary depending on your data. So those are my positives. And then I've got negative 1, negative 2, negative 3, negative 4, negative 5 meters per second in my negatives. So now my first one here I'm going to do is my pink one. Let's say that this one here is walking. So that one's my walking. My slope is 2 meters per second, and my slope is 2 meters per second the whole time. So I'm going to come up here and I'm going to find 2 meters per second. My velocity is 2 meters per second this entire time period of 10 seconds. Now, this is the trick. If this is my 0, then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My x-axes can be the same scale. So I'm going to maintain this 2 meters per second for that entire 10-second period. And I get a really long velocity line because it takes a really long time to go that speed, to get to 20 meters doing that speed. My red one here, let's call this one running. So back up. This is my walking. My red one here, we're going to do as running. And it has a slope of 5 meters per second, but that motion only lasts for 4 seconds. So I'm going to come up here to my 5 meters per second, but that motion only is happening for 4 seconds. So you can see here that it's faster, it's higher up on my velocity time graph, and going the same amount of distance takes less time. Then my negative motion, I've got to go to my negative quadrant to negative 3, and this motion takes 7 seconds. So you can see now I'm down in my negatives, And this is kind of a middle speed. It's not as fast as my running. It's not as slow as my walking. We'll call this skipping. It's not as deep down as that one's high, but it's also not as close to zero either. So that's my skipping. And the length of time each motion takes is represented on the graph as well as its velocity. So now your conclusion sentence is to compare and contrast slow, fast, and negative motions on this graph and this graph. So slow walking, what does it look like on a position time graph? What does it look like on a velocity time graph? Let's do tomorrow. Have a good day.